Naam, ripoti za TRC Mzundu TV zinatokea hapa ndani ya viunga hivi vya shule ya sekondari Kabuku Ndani, na lengo hasa kubwa liloweza kutufanya tuweze kufika hapa ni kuja kwa ajili ya kushuhudia namna ambavyo tehama inaweza kutumika katika swala zima la ufundishaji. Na kwa kuanza tunakwenda darasani, tutakwenda kuangalia somo la geography. Tutakwenda kuangalia namna kutumia tehama katika kufundisha somo la geography kwa kidato cha 4. Ambatana nami sambamba, twende madarasani, twende nikakupitishe ukaone namna ambavyo mwalimu mahiri wa somo la geography kwa kidato cha 4 anavyoweza kutumia tehama katika swala zima la ufundishaji, na namna gani ambavyo tehama inaweza kumsaidia katika ufundishaji na kumfanya somo lake liweze kueleweka kwa urahisi kwa wanafunzi.
Attention.
Good morning, students. How are you?
We are fine, thank you, sir. How are you too?
I am fine. Sit down.
Thank you, sir.
Okay, students. Today we are going to study about geography. The subject is geography. And especially today we are going to look the topic of map reading. Map reading and the interpretation. And specifically, we are going to study about gradient. We are going to study about gradient. Okay, students, have we ever heard about the word gradient?
Yes.
What is it? What is gradient?
Gradient is measure of the slope.
Is a measure of the slope. Clap the hand for her. It is a measure of slope. That is a measure of slope. Another definition, different definition from that one. Okay, that means under gradient we are going to look at how steepness of the ground is. How steepness is the ground is. How is it steep? How is it gentle? Or how is it undulating or not? So it may be steepness, that it may be gentle or steep. So how does it look like? So it is about the gradient. And that is about the gradient. So we say is a degree of rise or fall. So it is rise or fall of the land. Is the land surface rising or is the land surface falling? Gradient is shown in the same unit. It has same unit of measure. It means that under gradient, if we use a meter, in the denominator and the numerator also should be meter. If it is mile, in the denominator is mile and also in the numerator is mile. So it uses the same unit of measure. Another thing which is very important to know is that under gradient, the numerator is always 1. It should be 1. So a numerator should be should be always be 1. It should be always be 1. So when a numerator, that means it is the upper number. The upper number. For example, when you say 1 to 5, this is a numerator that we are talking about, and this is a denominator. So for a gradient, the numerator should be 1. Yes, it should be 1. So that is very important thing to note about it. That we may discover those things that we are talking about. So you have to observe that map. Okay. Now look closely at that map. Every group has this map. So look closely. Observe line XY. Have you seen line XY?
Yes.
Now from there you may identify the highest contour. And this is 600 and so on. So highest contour is this one. This is highest contour, okay? And this one is the lowest contour, okay? Now look at line XY and tell me which is highest contour. Yes? Highest contour. Highest contour, observe it. Yes.
Highest contour observed is 600.
600. Very good. It is 60. This is 600. This should be meters, okay?
Yes.
Yes. We have to identify lowest contour. Yes, lowest contour. Yes, and the back there.
The lowest contour is 100 meters.
Is 100 meters. Now this is highest contour and lowest contour. Now the formula says that we have to find the difference. The difference, that means we minus those highest contour value and lowest contour value. Okay?
Yes.
Now that means vertical interval is equal to 600 meters. Then you minus 100 meters, which automatically will get 500 meters. This is vertical interval. Okay?
Yes.
That is vertical interval. So when you want to identify a vertical interval, we take highest contour, then you minus the lowest contour, and then from there you get 500 meters, and that 500 meters is a vertical interval. Let us look here. Let us look here. If you look at this kind of contour, how they are arranged, you may see that this is 800, that is the highest contour, is it?
Yes.
And this one is the lowest contour. Okay? Others cannot see properly, I think so. So you can see that this is the highest contour and this is the lowest contour. Let us see about the horizontal equivalent. Now, horizontal equivalency is a distance in between those two contours, highest and lowest. So the distance between them, that is horizontal equivalent. So horizontal equivalent, OHE, is a distance is a distance between those two contours. Those two contours is the distance between those two contours. That means highest and the lowest. The distance between them. Okay? Now, you just look at the map which you have been given. There is real gradient that we are looking for. That is the gradient that we are looking for. Remember, we say that the numerator should always be 1. Okay? And so we get 1/11. So the gradient from the map that we are looking for is 1/11. And that is the gradient. Now the issue is, what does the gradient mean? You have got our gradient is 1/11. This is our gradient. Who can tell me what does it mean? When you move in the horizontal distance by 11 meters, there is a rise of 1 meter. So as you move 11 meters away, then there is a rise of 1 meter. Okay? So the vertical rise is 1 meter, but the horizontal distance is 11 meters. Well, likewise, you may say, for example, if you move 11 kilometers, there is a rise of 1 kilometer as a gradient. Okay? So that is the relationship. So that means it shows the relationship between the rise of the ground and the horizontal distance. And that's why we use the horizontal equivalent and the vertical interval. That means we are going to see the relationship between the vertical movement or vertical distance and the vertical rise. So here vertical rise is 1 because you are supposed to move 100 meters and then there is only the rise of 1 meter. Okay? And if it is like this one, oh my friend, only 2 meters and there is a vertical rise of 1 meter. So it is a very steep. Here it is very steep. This is a very steep. That is how we get. So if this number is big, if the denominator, in another way, if the denominator is very big or it is very large, that means it indicates that the gradient is very gentle. And when this denominator is very small, it indicates that the gradient is very steep. That means you have to, it is very, very steep. So that is how the gradient is calculated.
For example, we are learning about plateau mountains. Plateau mountains are occurred between places, so it will be a plane, and then it starts rapidly, and then it is coming down rapidly. So the gradient of there, because it is sharpness, how can it be?
Okay. Gentle, that means the denominator down there is very big. So that means you cannot show the same two things at the same time. That means, and if it is what you are required is just to read those contours only. There is no need to escape from it. You have to read only those contours. Let's say for example, we have contours. These are very far away. Okay, but later on you find that they are very close together. Okay, but remember that they have the same number. They have the same number. For example, here is 20. Here will be 40. Here will be 60. Here will be 80. Regardless, they are very near or not very near. Okay, so that means you may be able to calculate whatever, because whether they are near, they are very close or not close. But what you consider are the contour numbers, because the contour numbers are there. That does not mean that when contours are very near, that means there is no contour. No contour there, you have numbers. So you have to control what is going to be determined here is just the distance will be small. If contours are close, that means the distance will be close, will be very small. And if contours are far away, that means also the contours, that the distance will be very big between them. So there is no difference when you say that there is a very close together or not close, but contour numbers are there, and therefore you will be able to calculate whether, regardless of how contours are arranged. Okay? Yes, so that is how I can explain.
Nikiripoti tokea hapa ndani ya viunga hivi vya shule ya sekondari Kabuku Ndani iliyoko kata ya Kabuku Ndani, halmashauri ya wilaya Ndani, mimi ni Chisco wa Tazama Ndani TV, Ndani DC.